Okay, question 12 in the June 23 A-level Edexcel exam series for A-level. We're looking at first differentiation from first principles. So it's important that you look at your formula booklet and they give you how to work out using first principles here. So we've got the formula y equals sine x, and we want to prove that dy dx equals cos x. So to start this off, first of all, dy dx, now we won't use this notation, we're going to use the same notation as the question. So dy dx, which is your gradient function, which is the same as f dash of x, is equal to the limit as h approaches to 0 of, and in this case we want to do, instead of f of x plus h, that's going to be sine x plus h minus f of x, which would just be sine x over h. Now they've given you a fair bit of information here. They've said you may use without proof the formula for sine a plus b, and again that's given to you in your formula booklet. So if we expand this bit out, I'm just going to do that in orange over here. So if we expand that out, sine x plus h, so following the way that's written, it's going to be the same as sine x cos h plus cos h, cos x even, sine h. So I can replace that there. So sine x cos h plus cos x sine h, and then the rest of it will be the same, minus sine x over h. Let's neaten this up by factorizing out the sine x's. So that will be sine x of cos h minus 1 . So that's factorized that out, and we've got the plus cos x sine h over h. Now from here I'm going to split that up into two separate fractions, and we don't need to use partial fractions. It's a nice simple one, they're both being divided by h. So that will be the same as sine x times cos h minus 1 over h. So remembering here that multiplying by that is still the same as dividing by h, so I've just written it like that to make it a little bit easier to see. And then from here we've got cos x sine h, so cos x times sine h over h. And an important thing that they've told you, so we want to be using this thing. If it says you may, that generally tends to mean as h approaches to 0, so as it tends to 0, sine h over h tends to 1. So that means this tends to 1, sine h over h, and cos h minus 1 tends to 0. So what we're going to say then, as h approaches to 0, this now becomes sine x times 1 . Sorry, cos h, that's the blue bit there, so that's times 0 even. And then we've got plus cos x times sine h over h, and we said as h approaches to 0, that tends to 1. And what that leaves us with then, as h approaches to 0, that cancels out and we're left with, so therefore the limit as h approaches to 0 will be cos x. So therefore dy dx, our gradient function is cos x QED. That's what we were trying to prove.